we can do operations with these as well. And we've got to consider the same idea. So let's do the operation first, if we can, and then simplify. Well, I'm going to write this 9 times cube root of 3 just together, because I think we're used to seeing it better that way. So 9 times the cube root of 3 is the 9 cube root 3, minus the cube root of 24. Well, I need to look at my radicand. Can I simplify the cube root of 3? No, there's no number times itself 3 times to get us to 3. So that square root, or that cube root, has to stay the way it is. Here I've got to think, is there a number inside of 24 multiplied by itself 3 times, and possibly multiplied by one more number that gives us 24? Well, I know if I think about my 2's and 3's, if I do 2 squared, I get 4, which gets me up to times 6, gets me up to 24, but there's still another 2 in there. So this is where that guessing and checking, you got to come up with the biggest amount. Well, if I think about 2 cubed, I really want to try to get this index number as my exponent. 2 cubed, 2 times 2 times 2 is 8, and then if I take that 8 times a 3, I get that 24. So this is equivalent. These are the same things. I'm just trying to come up with a number that has this same exponent as the index number. So then I can write this as 9 cube root of 3 minus, well, here, I have a cube root of a 2 cubed. That means the 2 gets to come on the outside. So a 9 cube root of 3 minus this 2 comes on the outside, cube root of 3. And then we think about, can we simplify that any further? Well, the cube root of 3, everything behind that coefficient has to be the same. They are. They're both cube roots of 3. So if I have 9 of them and then 2 of them, I want to take away 2 of them. I'd end up with 7 cube root of 3. So this one involved multiplication and subtraction. This next one, the cube root of 50a to the 7th times the cube root of 5a to the 6th. Let's go ahead and multiply them. They're both the same index, so I'm allowed to take 50 times 5. Oops. Don't forget when you're writing these, though, to write your index in there. So I'm going to take 50 times 5, which is 250. And then a to the 7th times a to the 6th. And you think, do they have the same base? If they do, then you add their exponents. So a to the 7th, a to the 6th. I'm going to add 7 plus 6 and get a to the 13th. Now we've got to try to come up with the biggest number cubed that's inside of 250. Well, we already worked with 250. So we know that I've got 5 cubed. 5 times 5 times 5 is 125. And then times a 2 gets us up to that 250. Then I look at a to the 13th. Well, is 13 divisible by 3? No, so we need to go lower. Well, the next number below 13 is 12. Is 12 divisible by 3? Yeah. So I'm going to write this as a to the 12th times another a, because I need that 12 and that 1 to get us back up to the 13th. This right here is the exact same amount as the original problem. We're just rewriting it. Well, 5 cubed, our goal was to get an exponent of the same index. That means the 5 gets to come on the outside. But we still have a cubed root of 2. That stays underneath that radical sign. A to the 12th is divisible by 3. So that means we have an a to the 4th come on the outside. And we have our leftover a underneath the radical sign. So we have operations. You've got to see what you can simplify first. Your goal is to try to get something to this power in all of these situations, and that takes some guessing and checking, and you'll start seeing that a lot of the numbers are the same as we work through these.